So good morning, good afternoon, good evening to everyone joining us from Ethiopia, across Africa, the United States, Europe, and around the world. On behalf of People to People, Bahir University and Anadach Group, and with the support of RFA and Arts Media, it is my great pleasure to welcome you to the second session of our AI webinar series, The Foundation of Artificial Intelligence, Understanding the Infrastructure Behind AI. Artificial intelligence is one of the most consequential technological transformations of our generation. It is already reshaping healthcare, education, agriculture, finance, media, scientific research, industry, and government. But AI does not exist in the cloud by magic. Behind every AI application is real infrastructure: hardware, software, connectivity, data centers, power, and big data. These are the 6 pillars that provide the foundation for our discussion today. For Africa, the question is no longer whether AI will affect our future. It will. The most important question is whether Africa will simply become a consumer of AI technologies developed elsewhere, or whether we will build the infrastructure, human capital, data, research capacity, and partnerships necessary to create, adapt, and govern AI for our own needs. Ethiopia is an important case in point. We have tremendous opportunities, a young population, expand universities, extraordinary linguistic and cultural diversity, growing technological capacity, and significant renewable energy potential. At the same time, we face challenges in computing capacity, connectivity, and data infrastructure, and human capital. This raises an important question. Using Ethiopia as a case in point, how should African universities transform their curricula, research, faculty development, and industry partnership to prepare students for an AI-driven economy while balancing access to global cloud platforms with investment in local and regional cloud, data, and computing capacity? Ultimately, technology must serve people. Can AI help a farmer improve productivity? Can it extend healthcare expertise to underserved communities? Can it improve education and financial inclusion, accelerate scientific discovery, and strengthen public services? And importantly, how do we develop AI that understands our language, our data, our culture, and our priorities? As we innovate, we must also address privacy, cybersecurity, misinformation, bias, employment, energy consumption, and responsible governance. Innovation and responsibility must move together. Our moderator and distinguished panelists, we are privileged to have outstanding group of experts and leaders with us today. Our moderator, Dr. Brahanu Alamayo, is a distinguished health economist, applied statistician, and educator with more than 20 years of experience in health economics, outcomes research, and advanced analytics. He brings extensive experience at the intersection of healthcare, data, and technology, including the design and implementation of electronic medical record systems. He currently chairs the AI initiative at Bahir University, helping lead efforts to build institutional capacity and advances the practical and responsible application of artificial intelligence. His unique combination of advanced analytics, healthcare expertise, technology experience, academic leadership, and commitment to Ethiopia makes him ideally suited to moderate today's discussion. Our distinguished panelists include Professor Chiche Nzeire, Chair of the Department of Internal Medicine at Bahir Medical College in Nashville, Tennessee. In addition to his distinguished career in medicine and academic leadership, Professor Nzeire has pursued additional training at Harvard in artificial intelligence, bringing an important perspective at the intersection of medicine, education, leadership, and AI. Mr. Adam Rubin is Oxford trained and deeply passionate about artificial intelligence, emerging technologies, and their potential to transform society. He is co-founder of Zantango Inc., a US-based technology company, and co-developer of Guia Health, a next-generation digital health platform designed to strengthen national health system across Africa and the developing world. His combination of technology, entrepreneurship, and digital health innovation brings an important global and practical perspective to today's conversation. We are also delighted to welcome Dr. Getai Bahir and Dr. Theodoros Kefreyohannes, who are both the CEOs from Gondar University and Deborah Brown University, respectively, who bring valuable expertise and perspective to this important discussion. Our first session, the sixth pillar that makes AI possible, will feature presentation by young engineer Lydia Alam and Rachel Tinkham. Rachel is a rising star in the AI ecosystem, bringing fresh energy, insight, and a forward-looking perspective to this rapidly evolving field. Together, Lydia and Rachel will help lay the technical foundation for our discussion before we move into the panel conversation on the opportunities and challenges of implementing AI at scale. Dr. Brown will also be there to supplement if necessary. And finally, I'm delighted to recognize Dr. Bakaru Wubshet, CEO of the College of Medicine and Health Science at Bahir University. Dr. Bakaru is an extraordinary and forward-looking leader who is determined to position Bahir University at the forefront of Ethiopia's emerging AI ecosystem. Under his leadership, Bahir University is moving beyond discussion toward implementation, including the signing of an MOU with RFP to collaborate on the development of an electronic medical ecosystem. This is precisely the kind of partnership we need. Academia, technology, and the private sector working together to move from ideas to implementation and measurable impact. Dr. Bakalu will conclude today's program with closing remarks, key takeaways, and strategic direction. A final thought, let me leave you with one thought. Africa should not be a spectator in the AI revolution. We should not simply ask, how can Africa catch up? We should ask, where can Africa lead? And where can AI enable us to leapfrog traditional barriers to development? The decisions we make today about infrastructure, education, data, research, investment, partnership, and governance will help determine Africa's place in the AI ecosystem for generations to come. Our goal should not simply be to bring AI to Africa. It should be to help build an African AI ecosystem developed with Africa, informed by Africa, and capable of creating solutions for Africa and the world. With that, it is my great pleasure to welcome all of you and to turn the program over to our moderator, Dr. Brown Walamayo. Thank you.
Thank you very much, Dr. Naugao. Appreciate for that introductory remark and for introducing our presenters and panelists. Good morning, everybody. Good afternoon or good evening, wherever you are. It's also my pleasure to welcome you all to today's webinar titled Foundations of AI, Understanding the Infrastructure Behind It. Thank you all for joining us. As has been stated, artificial intelligence is transforming how we communicate, learn, conduct business, perform research, and deliver healthcare. But have you ever wondered what actually makes an AI possible? Behind every AI application is a complex ecosystem of technologies and infrastructure pillars that we often don't see. For example, users submit a request using, for example, ChatGPT. The request travels across the internet. Cloud data centers receive it. Electrical power keeps the infrastructure running. Servers equipped with GPUs perform computations. Software coordinates the processing. AI models generate a response. And finally, the answer is returned to the user. every step and component in this pillar and in this process is essential. Removing any one of these pillars significantly limits and impacts AI capabilities. Today, we'll explore the 6 pillars that make modern AI possible, namely the hardware, the software, reliable connectivity, data centers, power structure, and big data. We will look at how these components work together and why each is essential for developing, deploying, and scaling AI systems. Specifically, we hope that today's discussion will help us answer an important question. For example, if you had the opportunity to advise governments, universities, or the private sector today, what are the most important things that they should do over the next few years to ensure that they are prepared to benefit from AI? So these are the kind of questions that we're going to ask our panelists today. So today Hello?
Sorry, this is Adam Rubin. Hi. Can I add one more pillar?
Hold on.
To the 6?
Yeah. Adam. When it is during the panel, you can add one. So let's continue with this framework, if that's okay with you. Okay. Thanks.
Sure.
Okay. Perfect. So today we're pleased to have 2 capable presenters leading this discussion. As Dr. Nauga has introduced, Ms. Lydia Alam is a software engineer at AWS, a very capable expert in this field. She will talk about the first 3 pillars, namely the hardware, software, and connectivity. And again, Dr. Nauga has also introduced Ms. Rachel Dangan, who is an adjunct professor at 2 prestigious universities, Georgetown University and University of Pennsylvania. And she's also a former director at Academy Health and also a podcast producer. So she will focus on the last 3 pillars, namely data centers, power infrastructure, and big data. Following these 2 presenters, we'll have a panel discussion on opportunities and challenges of implementing AI at scale in developing countries, and with a special emphasis on Ethiopia. Again, the panelists are Professor Chike, Mr. Adam Robin, Dr. Getao Baye, Dr. Theodoros Kefalogiannis, and also I have added, if we have time, and I will add Dr. Jerusalem Bayena to chime in on some of the points that has been raised. So this panel will explore both the opportunities AI creates and the challenges of building the infrastructure and capacity needed to implement AI at scale, particularly in the Ethiopian perspective. Now, I look forward to an engaging and thought-provoking discussion. With that, let's begin our exploration of what makes artificial intelligence possible. And I leave the floor to Ms. Lydia to talk about the first 3 pillars. Lydia, you have the floor. You can take the screen and you can share your slides and tell us about those 3 pillars.
Okay, cool. I should be sharing my screen, so hopefully I can get a thumbs up if everyone can see it.
Yeah, we can see it.
Okay, cool. Yeah, my name is Lydia, and yeah, I'm going to be talking about the foundations of AI and what helps make AI possible. To get started, there are 6 key pillars behind AI. So there's hardware, software, connectivity, data centers, power, and big data. I'm going to be focusing on the first 3, which are hardware, software, and connectivity. I'm going to be talking about how they work together to help make AI possible. So moving on to the first pillar, which is hardware. When we talk about AI, we usually think about the software side. People are really quick to think of AI as just ChatGPT or AI assistants or image generation. But behind every single one of those applications, there's something really physical happening. AI requires computers, processors, memories, etc., a lot more. So before we can even talk about the intelligence of AI, we have to ask, like, where is all this computation actually happening? That's going to get me started with the first point, which is CPU. CPU is the central processing unit. Easiest way to think about this is the human brain. So CPU handles many different tasks, runs applications.
Lydia, you are not sharing your screen. Only the first page, the title page is yes. Okay, thank you. Now we can see
Oh,
it.
okay. Sorry about that, guys. Okay, thanks for pointing that out. Yeah, so I will repeat. First, we start with the CPU, which is the central processing unit. This is most commonly, I always think of it as the brain. It handles many different tasks. It runs applications. It handles instructions really well. But when it comes to AI workloads, they're really different. So AI models require like a very large number of mathematical calculations that are often happening over a very large amount of data. So uh, while CPUs, they are really important, they just aren't up to scale when it comes to AI or just large scale AI models. Uh, that kind of brings me over to GPUs, which are really important because they help with parallel processing. So an example is like if you were to give one worker like 10,000 different calculations to calculate one by like one at a time, they would take a lot of time to do that. Whereas if you're able to spread it out and have like 10,000 workers computing 10,000 different calculations, that happens just a lot more faster. And that's like the more easy or the easiest way to explain the advantage of using GPUs. And then we also have TPUs. These are the tensor processing units. They're more designed for machine learning workloads. So we have all three. To simplify them, we have the CPUs, general purpose. We have the CPUs, which are uh, or the GPU, sorry, for parallel processing work. And then we also have the TPUs for specialized AI work. Hopefully everyone can still see my screen. And I kind of like to tie this back into like Ethiopia's use case. So when we talk about AI infrastructure, I think we have to recognize that a very significant difference between using AI. There's a big difference between using AI and actually building the infrastructure that powers AI. So a university can use an AI application like with a laptop and internet connection, right? Like we can just like log into ChatGPT and maybe using AI in that aspect. But when it comes to actually building and maintaining the infrastructure, building and maintaining like data centers is a really like huge different things that I think will be covered in a different pillar as well. But um so yeah, to tie this in for like an infrastructure or institution like the Bahir University, I think the question should be more focused towards like how do we build it shouldn't be how do we build our own massive AI data center. It should be like how can we like access AI computing power without having to build like a data center and such. Um, yeah, and then also for the last point of memory and storage, I think it's really easy to say that AI models and data sets can be extremely large. So I think maintaining it and having storage for that is really important. So um, let me see, moving on to our second pillar, which I hope everyone can see.
Yeah, we
Uh,
can see it.
cool. Okay. Now we're moving from the physical side to the software side. So that's where our second pillar is. Hardware gives us the computing power, but it doesn't really know what it wants to do unless we actually build the models and process the data and create the applications for it. So I am not going to talk too much into each of these because they can get a little bit informative. But I think the first one is Python. This is just commonly used as one of the programming languages when we're uh, building AI work. So it's just a really common programming language. It's really accessible. There's like a lot of documentation online, so it's just a commonly used programming language. And then we have TensorFlow and PyTorch. These are just frameworks. So um, I think like an example is, I think my teacher actually told me is when it comes to like building a house, like you don't want to build every single tool that you're going to use to build your house. You're not going to like build the individual components. You can use frameworks that are pre-existing, that have pre-existing tools that you can use to help build your own AI applications. And then we have APIs as well. I think this is perhaps one of the most important concepts for organizations that want to start using AI. This is because you don't need to necessarily train your or build your own AI model. Like an example in our use case is if you wanted like Bahar to build their own AI powered educational application, you can use some existing applications and like change and add what components you need through APIs. To tie these all in as well, I think these are really important when it comes to environments where resources are pretty limited, which can be in a few universities in Ethiopia. So the question should be, how can we use software and APIs to create our own like AI applications or solutions for universities? Um, yeah, I'm gonna move on to our third pillar, which is connectivity. Um, for connectivity, I like to start off with a simple question, which is like when you ask an AI assistant or ChatGPT a question on your phone, like where is the AI actually running? In many cases, the heavy computation isn't happening directly on your phone. It's actually happening elsewhere in a cloud infrastructure somewhere else. And the connectivity is what allows our device to actually connect to the cloud infrastructure to be able to ask and get an answer um, from our question. So I think the first point is broadband. And I think at its simplest, it's just having connectivity needed to access the digital services. For AI, that connection is what allows like our phones and laptops and other systems to communicate with the computing infrastructure elsewhere. The more AI becomes part of our like everyday services, I think the more important it is to have reliable connectivity. So, uh, moving on to the second, which is the cloud. The cloud is a physical infrastructure. These can be sometimes seen as like data centers. They're filled with like GPUs and a lot of the hardware aspects. So um, that's where the cloud can be or comes in really important. So um, I like to again tie this into like Ethiopia's connection. So for Ethiopia, this creates like a cool opportunity I do see. So like since it can be oftentimes difficult to have our own resources to like independently build our own AI infrastructure or build like data centers, we can leverage like infrastructure that already exists through cloud services with other partnerships like AWS and such. And I think that we can move it from like how do we have our own infrastructure to like how can we access other infrastructure and use that in our like use cases. And then our third point, which is low latency. So latency is the easiest term. It's just the delay from making a request to getting a response. Uh, I could talk about it a little bit more. An example is like if you were to use ChatGPT to ask you like, oh, or if you were to ask ChatGPT like, how do you write an essay? Like obviously the latency in those cases are not that important. Like if our responses are slow, it's not that important to us as versus where when it comes to like self-driving vehicles or like medical devices, that's when like latency becomes like a really important factor. Um, yeah, and then for edge computing. Uh, Edge computing, I think it's instead of just sending every piece of information to like a distant data center, sometimes the computation can actually happen a little bit closer to where the data is generated. So I think the goal is just to reduce the distance data has to travel, which is what edge computing does. Oh, okay. Yeah, for closing statements, I like thank you guys for listening in. I don't know if you guys have any questions or might have to wait for that, but I hope this was able to give you like a little bit of a better understanding of the f first three of six pillars, maybe seven now, but yeah, thank you for listening in.
Thank you very much, Lydia, for that. I appreciate that. So you saved that few minutes. That's great. We were short of time, so great. So, Rochelle, it's yours. The last three pillars. Take it over.
Wonderful. Thank you so much. I don't know, Dr. Berhana, if you saw the link that I shared to share the slides. We consolidated them a bit in the interest of time. If you're able to share those, I can go ahead and get started.
Okay. Did you through chat or by email?
Both. Email may be easiest.
Okay. Oh, do I see the? Okay, let me check my email. Go ahead. You can talk.
Sure.
Okay, let me check my email. Sorry about that.
Okay. No, it's no problem. Yeah, so in a sense, I'll pick up where Lydia left off, and I will present on three different areas. First, on the data centers themselves, which she had just described, and then also tied in some emphasis on the implications of data center creation for the power grids, and then some key considerations related to the use of big data specifically. So as Lydia mentioned, these data centers function like the physical home for the hardware, which then is used to run the software and the other related technology and equipment associated with supporting AI computing. As mentioned, a lot of energy, effort, and resources go into creating these data centers, and they can have complicated implications for the surrounding environment. However, there are also some potential benefits associated with housing a data center or constructing a data center in a community. For example, oftentimes the construction of a data center will involve a company or corporation, a Google and Amazon, contributing resources, financial and otherwise, in order to ultimately expand the power grid that is required on which these systems run. And so the end result is that you actually can have some, that's perfect. Thank you so much. You can actually have some expansion of the power grid and thus expansion of the capabilities in a particular region as a function of this investment. Often there are some questions and considerations regarding whether this is too expensive an effort in certain areas, but it can also be extremely lucrative and bring a lot of attention and benefit to a community. For context, right now, of the data centers currently established in Africa, there are several in South Africa, in Johannesburg and Cape Town. There's one in Nigeria, Kenya, and Morocco, but that's it. So there are immense opportunities if the construction of data centers is done in close collaboration with governments and other potential partners, and also if it's done in ways that are energy and resource intensive and that ultimately give back to and expand the infrastructure of a community rather than simply detracting from it. So as you can see here, if you want, if you press slideshow, it may put it into presentation mode.
Okay, let me see. Hold on. I cannot. That Google Doc, is that what you send me?
It's Google Slides. If you press slideshow at the top, it should just play it. Meanwhile, for folks who are viewing, what you see on the screen here is an example of images from a data center, a Microsoft Azure data center located in Cheyenne, Wyoming, just to give you a visual reference so that you can get a feel for what these data centers look like. And it may just look like a space for housing lots of specialized computers, but this functions more like an integrated ecosystem, which includes all of the servers and the data storage resources, but it also includes things like the heating and cooling system and the surveillance mechanisms required in order to keep the system up and running and functioning, as Lydia described, and then also to help with cooling, which I'll talk about in just a moment. Great, this is perfect. Thank you. So I just mentioned cooling. It takes a significant amount of energy and resources to source, store, and then ultimately analyze the data. And as a result, these systems can generate substantial amounts of heat. So air and liquid-based cooling are often used to help maintain safe operating temperatures. There's some speculation about whether or not these cooling activities, particularly water-based cooling activities, are environmentally sustainable, but there are some new initiatives that have been used to help ensure more environmentally responsible approaches to water-based cooling. So for example, using non-potable or recycled water. Some you may have heard have speculated about the value of putting these data centers underwater for sake of helping to keep operating temperatures cool. And there are other ways that some of these companies are investing resources and also helping to build the surrounding environmental infrastructure. I have heard speculation that some data centers actually end up running on less water than a golf course, to give you a sense of the type of resources we are talking about here. Lydia touched on the second point here, the power grid. Again, reliable and continuous electricity is needed to support data center function. And as a result, in the event of some kind of an issue or the system going down, often there's a power distribution plan. So power can be distributed across multiple locations, or there are backup generators and UPS systems that are used to help ensure sustainability. In terms of storage, there's the need not only for the physical storage space in terms of the buildings that I just showed, but also the other resources that are needed to house and then analyze over large data sets, different model parameters, and the storing of logs and required documentation, thus requiring high capacity and high performance storage. And then finally, in terms of security, there's a requirement, especially when dealing with sensitive data, which is critically important for health and medical care and patient related data, for controlled physical access to the data centers, and then also cybersecurity protections, which I'll talk about in just a moment. Do you want to go to the next slide? I'm not sure what this yellow box is on screen. Apologies for that. So here I've flagged related to these data centers several key considerations, and I'll cover these before I get to the final pillar. There are significant implications, good, bad, and otherwise, associated with using AI technologies. I mentioned some of the environmental considerations, so I'll start there just to build on what I was saying before. These centers can consume significant amounts of electricity and water, and can also have implications for the community, which is why it's especially important to ensure that new development projects are kind of co-developed and co-created with input from governments, those who have expertise in the local infrastructure, and then also communities themselves and academic institutions, which is part of why I think this particular collaboration that P2P has established is brilliant and quite rare in this ecosystem. In terms of addressing some of these other key considerations, I'll start at the top. With scalability, it's very important that different communities have the opportunity to be able to grow and scale their use of AI technologies, especially with the rise of open access technologies. However, given bandwidth issues and some of the limitations associated with this work, it can be important to build these new data centers in new areas so that growing organizations, companies increasingly using AI, and populations that are growing themselves are able to scale this AI activity. That can create, in essence, the need for geographic distribution of this work. So sometimes organizations will operate multiple data centers in different regions or different locations. That can improve system resilience and response times when they're using AI technologies. So if one system goes down in one region or one area, ultimately it doesn't interfere with the quality of their processes and activities. In terms of efficiency, this geographic distribution also supports increased efficiency by helping to keep operating costs and energy consumption low. And again, I mentioned the water and air-based cooling, but there's also been increased reliance on renewable energy sources to help power the systems in the first place, solar, wind, and hydroelectric power. And then finally, I mentioned the grid capacity. Again, these data centers are resource intensive, and they may end up competing for electricity with other existing businesses and industries in an area or in a region. So that is, again, part of the reason why it's especially important for the construction of these data centers to be established, planned for, and conducted in collaboration with local communities and other businesses that may be impacted, but may also then be collaborators and strategic partners in the work. And you can go to the next slide then. And finally, this is the last pillar. So I had touched on data centers and the power sources. The last pillar is, I believe, one of the most important and critical parts of this work. It's the use of big data, which function like the fuel for AI, on which these models are trained and run. Again, the data themselves and the quality of the data dictate the quality of AI-generated outputs. Ultimately, the effectiveness of these AI technologies to generate unbiased, representative, and accurate responses depend on the extent to which the data on which they're trained are unbiased, representative, and also accurate. Machine learning models will learn patterns from training data sets, and once they essentially learn a particular template pattern from one data set, they can then track that same pattern. So when you provide a new data set, they would look for the same pattern and the same sort of system of relationships between some of these data points. And so the quality and the representativeness of information in that initial data set can strongly influence whether or not the model is actually trained to perform efficiently and effectively when given new data sets to run over. And that data preparation and curation work is especially important, making sure that data have been cleaned, labeled, organized in such a way that an AI-driven system can sort of pick up that information and quickly and readily work with it. I'll come back to data bias in just a moment, but data governance and provenance are significant. Yeah, on this slide, thanks. Data governance and provenance are significantly important in terms of avoiding the potential risk for harm. This is especially true in clinical and medical settings, in which case an incorrect or misdiagnosis of a condition based on a poorly programmed pattern recognition or a poorly programmed model could have implications for people's health and well-being. When we talk about governance, we talk about the policies for collecting, storing, accessing, sharing, and managing those data. And when we talk about the provenance, we talk about how an algorithm has been trained, what are the data elements from which that algorithm is pulling, and then ultimately, how has that information been passed from person to person, and what role did each person or entity play in the course of preparing those materials and resources. That helps with addressing AI-related responsibility and liability, especially in cases where regulation is unclear, where, for example, a hospital or health system may have one system of policies and practices, a data collection center or researcher may have another system of policies and practices for high-quality data. And those things may be conflicting. So having that kind of written record, or someone refer to it as a nutrition label for an AI model or a data set, can help people have transparency and see very clearly what's included and how a system was created. And then finally, I mentioned data privacy and security, the physical security associated with the building, the surveillance and access to the building, but also the cybersecurity protections associated with making sure that patient data and other data that have been collected are recognized as sensitive and protected as such. And then finally, I'll quickly touch on the data bias piece. Again, low quality or unrepresentative data automatically introduce bias into AI systems. So I'd like to give this quick example. I once asked, in this case, ChatGPT, to create an image of people attending a conference. And when it generated the image, it showed thousands of people, very diverse in a conference space. But if you looked closely, every woman in the visual was wearing a pair of black heels. And anyone who's attended a conference knows that typically you wouldn't want to wear uncomfortable shoes. But the bigger issue was that clearly the model had been trained on images of women in professional wear who were all wearing a pair of black heels. And so it signaled, because the training data were biased, that there's an inherent bias toward women wearing black heels at a conference. And so that goes to show that if the model is trained on a system of images or a data set that has an inherent assumption built into it, that inherent assumption then gets perpetuated through the outputs, which is why it's especially important for these data sets to be developed in a way that honors sort of the five V's, or optimizes the five V's, which are the characteristics of high quality data. And those are the volume, velocity, variety, veracity, and value of data. Just very quickly, when we're talking about the volume of data, we're talking about sort of the amount of data. Larger data sets provide more data points and ultimately make it possible to learn more complex patterns. Lydia touched on the second V, velocity, which relates to the ability to process data in real time. And in some cases, the physical proximity of one of these data centers to the location where the sort of input prompts are being issued can in fact improve the quality, accuracy, and responsiveness of the system. Variety relates to the types of data. So you can have structured, semi-structured, and unstructured data. That can include data in different forms: text, images, audio, video, sensor readings. And again, this is especially important in the context of clinical care, when, for example, a complex medical case might benefit from pulling data in different formats from different sources. So you might have an image from a dermatology scan, quantitative data from a lab result or survey, and then also written and verbal data from a patient and provider encounter. And then the last two, veracity refers to the accuracy and consistency of the data, and the value relates to the extent to which meaningful insights can be generated from the data. And with that, I will close out and pass it back to Dr. Bahir.
Thank you very much, Rachel. That was right on time and very informative presentation. Appreciate that. So let's start, and then I know Adam wants us to add some, but I'll give you a chance. Adam, just give me a chance to close this. So just to closely, I have one slide just to summarize what we have just discussed so far. So let me just put this in a presentation mode again. So what the two presenters have taught us today is that this is what AI needs. For example, users interact with like some kind of AI application like ChatGPT. The request goes through the internet, and the request reaches these cloud providers where data is stored, and then that data centers and infrastructure are powered by reliable electricity, and then then power runs high performance servers like GPUs that perform this massive parallel computation and processing. And then the software systems like drivers, frameworks, and libraries manage the hardware and do the workload. And then finally, the AI models that are trained, as Rachel has said, analyze and input and generate the prediction of what is required, and then the response goes to the user. So this is just in a nutshell what has been discussed today. So with that, what I like to do now is let me stop sharing my slide.